Welcome to G Fun Facts Online. Today we're talking about monsters. Not the kind from fiction, but real-world behemoths of wind and rain born from our oceans. An era of superstorms is upon us, and there is a growing body of scientific evidence suggesting that human-induced climate change is making them more frequent, more intense, and more destructive. These monstrous storms are not only real, but our warming planet is fueling their rage. Let's delve into the intricate and alarming relationship between our warming planet and the rise of these super typhoons. First, what exactly is a typhoon? Think of it as a giant, rotating engine. It requires a very specific recipe to get started. First, you need a warm bath. Ocean water at least 26.5 degrees Celsius, and deep too, down to about 50 meters. This warm water is the primary fuel, providing the immense heat and moisture the storm needs to power itself. Then, you need atmospheric instability, meaning the air is ready to rise, allowing for the formation of towering storm clouds. Next, add high humidity in the lower and middle atmosphere. This moisture is the fuel that gets converted into the storm's energy. You also need the spin of the Earth itself, the Coriolis force, to get the whole system rotating. This is why typhoons don't form right at the equator, where that spinning force is too weak. Finally, you need a pre-existing weather disturbance, like a cluster of thunderstorms, to act as a seed. When all these conditions align, the process begins. Warm, moist air over the ocean rises, creating a low-pressure zone. Air from surrounding high-pressure areas rushes in, gets warm and moist, and rises too. As this air ascends, it cools, and the water vapor condenses into clouds, releasing a massive amount of energy called latent heat. This warms the surrounding air, causing it to rise even faster, creating a powerful, self-sustaining feedback loop that can spin up into a terrifyingly powerful storm. But not all typhoons are created equal. The term super typhoon isn't just for drama. It's a specific, terrifying classification for the most intense storms on the planet. The U.S. Joint Typhoon Warning Center gives this label to storms with sustained winds of at least 241 kilometers per hour. That's the equivalent of a top-end Category 4 or a Category 5 hurricane on the Saffir-Simpson scale used in the Atlantic. Other agencies have their own definitions. After the utter devastation of Typhoon Haiyan in 2013, the Philippines Weather Agency, PAGASA, created its own super typhoon category for storms exceeding 185 kilometers per hour. This was a crucial recognition that these storms represent a different class of threat entirely, demanding a higher level of preparation and response. This is where climate change enters the picture, acting like a steroid shot for these storms. The Intergovernmental Panel on Climate Change, or IPCC, has stated with high confidence that human-caused climate change is directly increasing the extreme rainfall from these cyclones. The most direct and well-understood link is the warming of our oceans. Our planet's oceans have absorbed about 90% of the extra heat trapped by our greenhouse gas emissions. This means the primary fuel for typhoons, warm water, is now more abundant and hotter than ever before. For every single degree Celsius of increase in sea surface temperature, a storm's potential intensity can jump by 5 to 8%. That means stronger winds and more destructive power. A 2015 study projected that the intensity of typhoons in the Northwest Pacific could increase by as much as 14% by the end of the century. But it's not just about the wind. A warmer atmosphere can hold more moisture, about 7% more for every degree Celsius of warming. So when a typhoon forms today, it has access to a supercharged fuel tank of water vapor. This leads to biblical-scale rainfall and, consequently, catastrophic flooding and landslides. To make a terrifying situation even worse, global sea levels are rising. This is happening because water expands as it warms, and because glaciers and ice sheets are melting. This rising sea level gives the storm surge, that terrifying wall of water pushed ashore by the storm's powerful winds, a dangerous head start. A more powerful storm pushes a bigger surge, and that surge starts from a higher baseline, allowing it to sweep further inland and cause more extensive flooding than ever before. This isn't just theory. We've seen the horrifying results in the real world. Many of us remember Super Typhoon Haiyan, known as Yolanda in the Philippines, back in 2013. It was one of the most powerful tropical cyclones ever recorded at landfall, slamming into the country with sustained winds of 315 kilometers per hour. The storm surge it created was likened to a tsunami, wiping entire communities like the city of Tacloban off the map and leaving over 300 people dead. It was a global wake-up call to the potential of these storms. Then in 2016, Super Typhoon Meranti became one of the most intense cyclones on record. A key feature was its rapid intensification, a phenomenon that is becoming alarmingly more common as our oceans continue to warm. And just before Christmas in 2021, Super Typhoon Rai, or Odette, devastated the Philippines again. It was a Category 5 super typhoon that brought a deadly combination of violent winds, torrential rain, and storm surges. A scientific attribution study on Rai concluded that human-caused climate change made the extreme rainfall and high winds observed during the storm significantly more likely and intense. The destruction from a super typhoon doesn't stop when the wind dies down. It triggers a cascade of secondary disasters. The intense rainfall overwhelms rivers, causing widespread flooding and deadly landslides. The powerful winds obliterate infrastructure, buildings, bridges, power lines, knocking out power and communication for weeks and crippling response efforts. Agriculture is decimated. Super Typhoon Rai, for instance, affected over 460,000 hectares of agricultural land, leading to long-term food shortages. And the aftermath, with contaminated water supplies and displaced populations crowded into shelters, can trigger severe public health crises. The economic toll is staggering. Studies have found that while smaller storms have short-lived impacts, a single intense typhoon can slow a country's economic development for more than a decade. So what does the future hold? The scientific consensus is clear. As our planet continues to warm, the threat from super typhoons will only grow. Climate models project that while we might not see more storms overall, the ones that do form are far more likely to become intense. Category 4 and 5 superstorms. Projections for a 2°C global warming scenario show average tropical cyclone rainfall rates increasing by about 14% and intensities increasing by up to 10%. We are in an era where the storms of our past are being transformed into monsters. The science is unequivocal. We are feeding these beasts. The path forward requires a two-pronged attack. First, mitigation. We must drastically reduce our greenhouse gas emissions by transitioning away from fossil fuels and towards renewable energy. The sooner we act, the less severe the impacts will be. Second, adaptation. We must prepare for the climate change impacts that are already locked in. This means building more resilient infrastructure, developing far better early warning systems, and protecting and restoring natural coastal defenses, like mangrove forests and coral reefs. The stories of resilience from communities rebuilding after storms like Haiyan and Rai are a testament to human strength. But resilience alone is not a strategy. We have to address the root cause. The rise of super typhoons is not a distant future problem. It is a clear and present danger, a stark warning from our planet that the time for decisive action is now. Thanks for listening to Fun Facts Online.